In February 2017, about 188,000 people were evacuated downstream of California's Oroville Dam. Water had damaged the main spillway, and erosion was threatening the emergency spillway. So, what did the weather do to make a reservoir crisis escalate this fast? The answer starts before the dramatic footage. Oroville sits below the Feather River watershed, a huge mountain catchment holding both a lake and a winter snowpack. Several storms had already been feeding the basin. The next one arrived with a very specific kind of fuel. An atmospheric river is a long, narrow conveyor of water vapor inside a storm. In early February, one pushed warm, moisture-rich air into Northern California. That matters because the storm was not only carrying a lot of water. It was carrying water high enough into the mountains to change what happened to the snow. The rain-snow line is the altitude where falling precipitation changes from rain to snow. During this sequence, the freezing level was unusually high. More of the storm fell as rain across the Feather River Basin instead of being parked temporarily in the snowpack. Rain also landed on snow that was already there. The mountain had stopped acting like a freezer and started acting like a funnel. That funnel was already wet. Earlier storms had filled soil pores and altered the snowpack. Hydrologic studies show that rainfall can route through snow, while progressively wetter soil leaves less room to absorb the next pulse. So the second or third storm does not meet the same basin as the first one. More of its water becomes direct runoff, and the river responds faster. Now, add the timing. The trailing edge of the storm stalled over the Feather River watershed. The inflow kept arriving while Lake Oroville was already high. California's timeline records more than 1 million acre-feet of inflow since February 6, and the lake rose above 901 feet. Operators had to use the main spillway, where a large damaged section had already appeared. When the lake reached the emergency spillway, water began moving over a route that had never been used in normal operations. Erosion threatened the hillside below it. The warning was not, "The dam has failed." It was that continued erosion could undermine the emergency route, putting roughly 188,000 people in the potential path of water. Evacuation was the safe decision while operators worked to lower the lake. Releases through the main spillway resumed, the lake level fell, and Oroville Dam did not fail. The detective lesson is the chain: warm moisture in the storm, a high rain-snow line, rain on existing snow, a watershed already getting wetter, and a storm that stalled at the worst moment. For mountain flood risk, rainfall is only the headline. Snowline, soil wetness, and reservoir room tell you how quickly that water can become a disaster.